Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream where today we're going to be making my compiler for my 16-bit virtual machine programming language a little bit smarter. Currently, all of my result variants return error. Let me show you what I mean by that in case it isn't clear. Let me just set up another recording real quick. There we go. Let's clear that. We don't need to see any of that. What was I doing again? Oh yeah, language. If I look at all of my parser combinator functions that I use for my parser combinators, the results, all the error variants are strings. And this kind of sucks. This means that if I run, if I try to compile a program, bin lang, if I try and run my test program, I get this error, and you know, if I look at the file, you can kind of maybe guess, return got if, you can kind of maybe guess what happened, but it's not very clear. It's not very clear where in the file it happened, and so if I undo all my stuff, and we look at, you know, what I was actually trying to compile, well, this is actually another problem. Actually, let me add, like, goal 0. Let me go back here. Goal 0 is going to be, don't quietly fail on function defs. Yeah, okay, I think that's good. And we'll probably actually do this first. So we have this primary issue -1, before we even get into everything else, which is that when we try and compile this file, we want this fib function. Something goes wrong when we try and parse this first statement, and I'm not totally sure what yet, but we're going to work it out. But because this fails, because of how I've defined my parser combinators, if I look at define, function define is actually okay, I think, function definition. But if we look at this, parse AST, it just repeats. It says at least one time, but as many, like one or more times, do this thing. Okay, so what happens when we try and apply this to this file? Well, it parses main, and that's all good. We're happy with main. And then we get down to fib, and it tries to parse fib and it fails. But the way repeat works, well, if it fails to parse it, we move on to the next thing. So this actually doesn't work. Right, this actually doesn't work, and I think probably what we need to do for the AST is something a little bit more involved than repeat. We probably need to do something a little bit more special. So let's maybe handle this first, right? If we find a function, we have to try and parse it as a function. Indeed, if we can't do any of these things, that might actually be an error because, well, we want to keep doing this until we reach the end of the file, basically. That's how we want to encode this. So let's try and write that instead. So let's use this pattern we've used a couple of other places. Let's make an out vector. Vec new. Let's make a current state variable, which is going to be our input. Now we're going to say loop. Okay, and we might find a better way to write this once we've written it out in a very imperative style, but we're going to start with this very imperative style. I think this is good. I think this is a good way to think. Let me just move this pop filter. That's blocking my view a little. Okay, so loop. Now what do we want to do? We want to keep trying to parse the next thing as long as there is anything left in our input. So let's say if current state.is empty. Actually, no, because we don't just care if it's empty, right? So again, what if we go back and look at our file, right? This is all fine. This file's fine. We have one whole function, we have a second whole function, then the file ends. But what if we have a couple of new lines afterwards? Well, in that case, we want to make sure we skip these new lines. In other words, we want to make sure we skip the white space. So let's go let sn, the sn in this case meaning state next. Maybe I should call it state next. And we don't care about the result. It's skip white space. Current state. Right, so whatever is in the current state, we advance past any white space. If we hit the end of the string, what happens if we hit the end of the string? Have I considered this? I'm not sure. I actually don't know Surely I've handled this because surely, what's it called? Character? Yeah, okay. I do this some cars next. So the fact I handle the case of the empty string. In conclusion, that's fine. So advance any white space. If state next is empty, then we want to return. Then we say, okay, we've finished parsing our AST. We've parsed everything. This has to consume everything in the input. We don't want anything left over. So we say, okay, state next, which is just going to be the empty string, but we'll pass it out like this anyway, and the vec, the output vector. Awesome. Otherwise, we've got a next state that contains some stuff. So now we want to say, we want to run this any, but we'll actually say we'll define this up here because otherwise we're going to have to do this allocation inside the loop, maybe. Function definition. Right now it doesn't really matter because it's actually, the only thing we care about is function definition. So otherwise we'll let SNN, which is state next, I guess, TL or res is any.run. We run it on the state next with this little unwrap. Yep, we grab this, we push the result into the output vector, and then we say current state equals SNN. So this is the same thing, right? This is the same thing we had before. I guess a little bit more risk of an infinite loop, but you have that risk anyway with parser combinators if you're not advancing and consuming your input properly. I think this is okay. Let's build it and see what happens. Well, it yells at me, of course. Of course. The trait function stir is not implemented for stir, which is required by... Yeah, that's a good point, isn't it? Skip white space. How do I define skip white space? I actually want this bit because this isn't wrapping... this isn't wrapping something. I actually want to just use like the inner bit. Discard this. I want this. The bit where I just throw away anything that is white space. Yeah? That's good. And that seems to work. That really does just seem to work. So if I run this against my test code, we get something that, I mean, it's still an error, but it's the error we kind of expect, which is good. So it's still telling us that the problem's here, but I only know that because I understand how my parser combinators work. Bobbius comes into chat. He can use a plus address to get a new email to register a second account under. Yeah. Bobbius2, welcome. Did you lose... you lost access to your Twitch account, right? There was some really silly thing here. Yeah. So yeah, for anyone who doesn't know, that's a really cool thing, by the way, just a quick side note. So my domain is like, my main email that you can reach me at is tom@tommarks.xyz. But if you put a plus here, you can put anything. You can put anything after a plus. They all map to the same inbox. They all map to tom@tommarks.xyz, but you could say tom plus Twitch if you were signing up for Twitch. And then you know that when all of the emails come into this, they're coming from Twitch. So it's really good when you sign up to a service, because then when you start getting spam emails from like, Tom plus Woolworths, you know that's who leaked your email address. I'm not saying that Woolworths would do that. There's no slander here, right? That was just an example. That was the first company that came into my head. Yeah, Bobbius2 lost his phone for 2FA. Now, this is always a disaster, right? Make sure you have a 2FA backup plan and test it. I broke a phone. I bought my email plan, right? Because I have my own domain. I pay for an email plan. I bought it. I set up 2FA on my phone, and then a few days later, that phone broke before I'd made a backup of my OTP stuff. So I lost access to the admin panel of that email. I could still reach the email. I just couldn't make administrative changes to the whole account. And that was kind of bad. That kind of sucked. I tried really hard to get data off of that phone and I couldn't do it. It wasn't on the SD card, it was like on the actual drive on the phone. And I was stuck. And it took, after a couple of weeks, actually, it took me months. I'll admit, it took me months to get around and deal with that. I had to ring them and like go through this whole process. It was a real pain in the ass. Yeah, Bobby has sent the information to Twitch. Don't expect a response. If your 2FA stuff breaks, like, it's good if companies can accommodate that, but really assume they're all gonna suck. Assume they're all gonna have horrible support and make it your own responsibility. That's the only thing you can reasonably do in this day and age. And you should have a backup plan, put your phone away one day and say, hey, okay, I need to log into this thing. What do I do? Like, practice your disaster recovery situation, because your phone is the key to the kingdom, but phones, they leave the house with you all the time. You're going to lose your phone. It's going to get cracked or damaged. Something's going to happen to it one day. Oh, but I don't want to sound too preachy as well. You gotta live life as well. You gotta have fun. Okay, so that's good. I don't know what that little floating help dialogue is. Oh, Bobbius. Yeah, no, sorry. It was actually Twitch migrating away from author. You're right. There was more detail here than I remembered. Let's just commit this real quick while we're here. Fix top level AST parse consumes all of input. I think that sounds good. I think that makes sense. Okay, so now we have this problem. And this problem is that all of our... Actually, hold on. I almost forgot to do my favorite thing in the whole stream, which is checking a box. Let me use a better color for that. We check that one off. That's done. I love it. It's beautiful. Okay. So all of these things returning string means that we get no context about where this error has happened, and that kind of sucks. That's actually pretty bad. So let's source bin lang. Do I put it in here? Let's call it parse error.rs, even though that... Actually, no, let's just call it error. Hold on. Let's just call it error.rs, and we're going to make an error type, okay, that we will put here instead of string. It'll be something called like parse error. So let's go enum parse error, and we're going to have a couple of variants. And actually, I think we're going to have two layers to this. I think we're going to have a struct called a parse error. Okay, this is going to have a string for the location it occurred at, and and let's actually call it context. Parse error. We maybe actually can just call this kind. No, it should be parse error kind. Okay, that's fine. So we're gonna have this type. And it'll take a context, which will be a stir slice, and a kind, which will be a parse error kind. It goes back a self, and this will just be a self with context, ctx to owned, and kind will just be whatever kind we parse in. So rather than just this normal kind of error enum, we will have like I don't even know. I actually don't know what our different errors are going to be here. For example, parse type. Yeah, I'm gonna pop this chat out real quick because this is actually I'm a bit distracted by how interesting this is. Your phone works. Too broke for a phone number. If you had the old number, they could text you, but they cut the legs up front of you when they left Authy, so they changed the way it works, and now you can't log in anymore, which is pretty bad. That's pretty awful. Bad thing to do. But yeah, in general, 2FA having multiple options is really good. And in general, having 2FA go to your phone is also, like, texting to a phone number is just a bad method of 2FA. I don't recommend this. You know, phone numbers are not something you will always own. Phone numbers are surprisingly easy to hijack, from what I hear. So yeah, let's keep this parse error kind, but let's maybe think about what this is going to look like. So for one thing, we're going to have a lot of map errors now, which is going to make this a bit messy. Map error, we're going to have some error message in a string that comes out of map repeat. Because if we go into character, actually we're not, right? Because alpha. So we're going to go into this most fundamental level. I actually don't know how many places... There's actually nowhere in this whole file that I seem to return and it actually deal with the fact that these return a string. I'm always wrapping things from up here. So that's kind of cool. That's kind of really cool. Okay. I'm getting the juices are starting to flow a little. They're just starting to flow a little. I'm literally like I'm winging this. I don't really know what I'm doing. Let's call this a parse error. Use crate. Okay. Parse error. I'm having this real thing at the moment with enums where I'm enjoying named fields more. But a really common pattern is we expected one character and we got another. So that's kind of good. We can do this really easily. So here we have expected secret. So we're just gonna say parse error new. We're gonna take the input. I think it'll be okay to take a reference to this. Sure, let's just take the whole input where this error occurs. We'll take this whole thing where this error occurs, and we're gonna have a parse error kind expected c got x. Nice. That reads very, very well, actually. Yeah, it's hard, like especially when you have two fields of the same type. I don't want to spend the rest of my life having to go back into this file and see which order they're defined in, like how to use them. So let's just name them. That's way, way simpler. The other error variant that's going to be really obvious is end of input, which is where the file has unexpectedly ended. Now, I see the typo, by the way, if anyone else is paying attention. I forgot expected car. Okay, that's good. That's good. So we're cooking. Parse error. Now. So maybe all of these really fundamental types actually. So these three functions, then alpha is just running this car predicate. So car predicate rather. This name, yeah, and I like that this is named as well. I thought this through. So this will have a very obvious path forward. So these 1, 2, 3, these 4 fundamental types should probably correspond to a specific error kind. So expected car not in car not in or car how do I describe this? So we have like this is a not, right? This is a falsy, so the character is not in a string. This is true when the character is not in a string. Unexpected car. Unexpected car is an okay name. I don't know if it wraps enough context. I guess we send information with it. So this would be, it will take a stir slice. it probably needs to be a stir slice with a lifetime, which means all of this is going to have a lifetime. Is that okay? Let's find out. Let's find out the hard way. So it's a stir slice and a car. And this one is actually unambiguous because the two types are different. So we're gonna go with that. We're gonna go with that. We'll see how this goes. We'll see how this goes. This borrow checker is gonna yell at me, but we're just gonna accept that for now. Parse error new input rather. Input parse error kind unexpected car, and we're gonna take this string. I don't know how this works with the the closure. I don't know how the lifetimes work. I don't know how they work. I guess the result it returns is tied to this lifetime, so that does kind of make sense. So we take the stir and the character that we got, and then this is just the end of input. Cool. Token, we're just going to have expected token, which again is good. I like this a lot. I like this a lot. The error is going to be parse error new input expected token, and that token is S. Been messing with Odin. Remind me what Odin is. Remind me what Odin is. Okay, and now we're just gonna have our predicate, and again we're gonna say car failed predicate. So we're gonna take the car and we're gonna take a string which is the name of the predicate, because this is a string for some reason. We'll clean these strings up later. Odinlang.org. Odinlang.org. Data-oriented language for scene software design. Oh, so it's another C alternative. So what does Odin bring to the table? And this is a loaded question. What does Odin bring to the table? As a person who's not going to read that entire website right now, what does Odin bring to the table that like Zig and Nim don't? And Rust. I don't necessarily love putting Nim in the same boat, but Nim is solid. I can't remember if I wrote Nim on stream or not many years ago, but I definitely have done a little bit of Nim. I should do a Zig stream. Zig's very cool. I just don't want to get distracted with more projects, like we've been joking about in my Discord. Okay, so character predicate. So now we're gonna say parse error new input what's this called? Car failed predicate. We take the character and we take the name of the predicate. And then this is another end of input error. Nice. Okay, so if I build this, it's going to yell at me for a bunch of reasons. One of them is going to be that we need to go into our lang main and we need to mod error. These all need to be pub. Okay. Now, yeah, so these need to have a named lifetime, and that is actually okay, I guess. So we're gonna do this. We're gonna do this. I'm always a bit scared of tying my errors to named lifetimes, because I always anticipate that errors may be longer lived than the data that is related to the function, right? We might need to pass that error much further up the call stack to give contexts to the errors later on. So I'm a little bit scared of doing this. Because if you think about where this is used, for example, let's look at a real example in character. If you look at token, right? Token is called, it passes a string in, but we might want to return this result. Like this result might get returned further and further out. It might get returned far further out than the scope of this. So I think these need to be strings. Please leave a comment on this video if I'm an idiot and I'm missing something really obvious here, but I don't understand how error types and borrow checker are supposed to work together, right? Sometimes they do, but in this case, I am imagining passing this data much further up my call stack than from where it originated. And if none of that makes sense, don't worry. It's okay. It'll be okay. it'll be okay. Excellent. So let's just do that. S.toString. We're gonna do a lot of thrashing. Nice. Okay. Parse error not found in the scope. That's because we need to use crate error. Now, I'm not actually sure if we need parse error kind, but we'll include it anyway. No, we won't. We'll be sensible. Only include things we need. Expected string found parse error. Character, blah, blah, blah. This is, where is this happening? 37, 65, expected string. I think I forgot to change the actual function signatures here. But yeah, no, I would be interested to hear what's up with Odin. So this is parse error, and all these need to be parse errors. And actually I can just do this as a multi-line find and replace. Okay, cool. Max. Ooh, okay. Now I kind of like this. We have this. Yeah, we can scope the state we pass into this error so that it shows us something a bit more useful, I guess. If that makes sense. Maybe it doesn't. Oof. Slices, dynamic arrays, matrix type, 4x4. That's kind of cool. Distinct types, bit fields, bit sets. Yeah, that's nice. Generics, kind of. Look, generics are overrated. Okay, get out of my compile time. If I need vex of things, I can. No, I don't know. I can understand why generics may not be a top feature. Okay, now we have this problem where we have these scoping things with the closure. So name, car failed predicate name on line 65. We need to just say toString, and this makes a copy. We're gonna need to do the same thing, maybe? Oh, we already do a toString. Okay, excellent. Discard repeat 0. Clone is not implemented for parse error. Now that is good news because we can implement clone for parse error. We can derive it, in fact. Derive, debug, clone. And this, I mean, this can just derive everything, right? Derive, debug, clone. I guess, can we do partial EQ? I think we can have that. Default. Now, default is also interesting. Default is also interesting. And why do we need default again? This is one of the inner things, right? It's for repeat. Yeah, it's for repeat. So if I look at repeat, why does this need a default? I don't think it does. Oh. I think that's actually fine. That's very funny. That's very, very funny. Now, can I just implement from parse error for string? Like, why don't I get this for free? Because if I come and implement... what am I doing? So I need to do it for this. Impl parse error kind. Right, if I implement display, what is it? Function... I can't remember how to write this function. I'm going to have to copy it from right here, thankfully. Right up the top of this file. Okay, so So display for parse error kind. Match self. Should probably wrap these in single quotes so it's clear we're dealing with cars, not strings. And that seems good. That seems really good. Okay, so what else do we have? Self, unexpected car. SC. X. Car. Not in. Not in. Not in. The double negative is hurting me a little here. It's hurting my brain. So if S does not... So car... Not in... Let's go with that for now and see if that reads correctly. Expected token. Henry, welcome. Hello. This is a weird time stream. It's good to see a couple of people trickling in. How's it going? I haven't seen you for a while. How is life? I haven't been streaming super regularly either. So yeah, how is life? Right. Expected token S. Car failed. Predicate. Bobbius says they still missed a ton of streams despite my irregular streaming. It's hard to keep up when it's irregular, you know? I don't make it easy for everyone. Henry says, what's up? Is it Henry? Is it Henri? Henry says, what's up with the PS2 project? It's ticking away in the back of my brain, but right now I want to do some stuff that's more applicable to life and easier to put on a CV. It kind of has to be my priority at the moment. But yeah, I still want to do a lot of cool stuff with it. I made some progress in some streams recently-ish where I got stuff running on the vector unit, which was cool. And yeah, so the PS2 stuff's happening. I'm always thinking about it. I'm always thinking about it. Once I get some of this stuff done, I will definitely reinvest some time. I'm like halfway through a big gross refactor. I wrote some stuff that diverged from the branch I'm on currently, and I've got to just like bring it all together. It's in a messy place. Enrique. Enrique, yeah, sorry, there's a QUE. I thought that was part of the next word. Oops. Oops. Sorry, I just clicked a weird button. I don't know if you just got a notification, but I clicked the wrong button. Do excuse me. Input. Okay. Thankfully, Twitch. To demo the project, download this ISO, run it in a PS2 emulator. Where's that from? Hold on. Wait, did I say that? Is that somewhere on my channel? What's... Or is that more just like the accessibility of what I'm doing, right? Like this is gonna run in a web browser. Oh, yeah. Easier to put in a CV, yeah. It doesn't really fly in an interview. It's like, oh yeah, you know, you just need to like dump the BIOS from your PS2 and you can do this all legally. That would be funny. That would be very funny. Okay, let's just do this for the wrapping error type. Now this is a little more interesting. So we just want to say write F. We want to write. Let's say we'll have the kind, and then we'll say at here. So we'll say self.kind, self.context. And I really don't understand why. Oops. 38. Right. I really don't understand why. Oops. Use std fmt. That also sounds good. Actually import the things we need. Love it. From parser is not implemented for string. So can I just implement this? Is this good practice? Like, what does the internet say about this? Rust impl from... Like, can I do this? Is this... Impl error. Impl error? That's okay. Transformation. Error type erasure. Makes no sense here. Different error types, blah blah blah. Consistent display. Yeah, okay. Error type erasure has its trade-offs. Useful writing something high level, blah blah blah. Yeah, so this is information for a cooler, blah 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 blah. Take error type is enough. More complex libraries. Okay, so actually, it's probably better that everything just deals with parse error here, right? And can I write a rule to do this? Result. Maybe let's see if we can do this. So we're gonna go result. Oh, I can never remember how to do this. Is it like... Nah, I can't do it. I'm not smart enough for that. I'm not smart enough for that. The problem is, like, you can write find and replace rules in Vim with, like, you know, :s. That will, you know, match this and just change this part of it, but I think you can. It's a really powerful little DSL, I guess. Would you call that a DSL? Is it just like a thing? Are they regexes? I think they predate regex, right? It's that classic old ed format. Which is older? Is ed older than regex? It probably is, right? It's very regex-like, but I don't think it's actually regex. I think it's one of those things. This is also maybe one of those cases where it's useful to have like a type iResult, which is like a st, and this is just a result st parse error, and then all these things just return an iResult. Right? That might be a thing worth investing in at some point. Not right now, but I mean, this, you know, would save me a bit of manual typing. It would allow me to retype all of my errors in one fell swoop. Would have been a good thing to consider, you know, a couple of days ago. But anyway, this will really come together quickly. I'm actually pretty happy. Again, I don't think either of you guys have seen it, but I've got like a full programming language. It doesn't have if statements, but you know, it's got like syntax, it's got variables, it's got function arguments, it's got locals, it's got most of the stuff you need for a programming language. If statement's pretty important. You know, some kind of loop would be really good, but we're getting there, we're getting there. Okay, now, 126. Discard, repeat, parser. Okay, everywhere we have result, it now... We're homing in. Now, again, we have this thing where in the combinator, repeat 1, error says it needs a default case, but that's actually just not true. That does not exist anymore. And I actually don't think we need clone either. Parse error. From string not implemented. Map repeat one alpha collect string. That's fine. So this just means it's in a string. Maybe ChatGPT could make one. Look, this is what ChatGPT is good for, but I also just don't like using it for these. I don't know. I don't enjoy that. I would rather bash my head against the wall and work it out myself. I would rather, put myself through that misery. Type from stir. Now this is a different thing. This is a very different thing. I didn't think of this. A different error, a different result, a result monad with an incompatible type. Despise writing regexes. Look, if you're writing regexes complicated enough that you despise writing them, I think you should reach for a different tool. This is my philosophy. This is how I remain in touch with not hating regexes. Okay, so we need to map this error. And we map this error from AST type. So we've parsed a type that is incorrect. So let's go parse error new input. And we're gonna say parse error kind. We'll say expected type, right? Why not? Why not? Expected type got whatever was that input there. Let's be really broad. Or no, not really broad. The opposite. Let's be really specific. Expected type. Let's be really specific about what these errors are. Expected type. Because that's what's going to give us meaningful error messages in the command line. Okay, and we're just going to say expected type. Beautiful. Okay, we're getting here. Parse error kind. Now we need to bring in parse error kind. We're homing in. We're going to ignore this thing. Trait bound combinator any. Not satisfied. Start parse error any new vec. Parse is not implemented. Well, that's not good. That's really not good. Why isn't this implemented? Map. So what's the error? The trait bound combinator any stir parse error result parse error parse blah 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 is not satisfied. Where F? So any has somehow stopped being a parser. That's not good. Yeah, okay. No, that's fair. I just live in Vimland, so I'm a little bit oblivious. I don't think I've ever had to do a search and replace so complicated that I've really needed like lots of trickery. The other thing that's worth considering if you have a really complicated search and replace, in my opinion, is doing it in 2 or 3 steps. Like transforming it, even if it's to something that's garbage, as an in-between step. Like if you're swapping the name of 2 things, cool. Like if you're swapping the name of foo and bar, cool one of them, like rename foo to bar 000 or something, and then rename bar to foo, and then rename bar 000 to foo. Like sometimes breaking these things down into multiple steps. That's a really bad example because you have to do that one in multiple steps usually anyway. But sometimes complicated refactors, rather than trying to come up with like the one magic solution, it's like, actually these are 5 small steps. And I'm going to do them quicker in 5 small steps than I am trying to big brain one magic solution. But working on my own hacker projects, my code bases are small enough. So let's clock this repo. Rust, 3,000 lines of Rust. Somehow, that's too. Hold on, whoa. Okay, that's better. Yeah, 2,000 lines of Rust. 2,000 lines of Rust, plus a bit more in the tests directory, I guess. But, small enough that I can fit the whole thing in my head. I'm not needing to use these big IDEs with all their fancy tools. Like, I can refactor just by hand with Vim. I was telling people about this at a Rust meetup the other day, and they were very concerned for my well-being. They were looking at me. They were like, "What is wrong?" Like I was telling them, I don't even have LSP. I don't even have like a red squiggly line under things. I just use my quick fix list. And they were looking at me. They were like, "What?" They were like, "What's wrong with you? Are you do you need help?" And the answer is no. That's good. You just write a lot of code, right? And then everything you just see it all. Okay, so STEF. Why has this ceased to be a parser? Why has this ceased to be a parser? Debug default. Ooh. Implement E. E default. This is it. So again, I don't think we actually need this anymore. Can I do this? E is left undefined. Okay, hold on. I gotta think about this. So any of these. So what happens if none of these match? We need to return an error, but we don't have an error to return because, so actually I'm gonna do something very controversial. I'm gonna do something very, very controversial. Clone st parser st. So this is a parser of option t. I think I actually had this before. I think I actually had it like this before. So f is a parser ste, and we're implementing parser s option te because if none of these match, we're just going to say okay. We're just going to say okay. Item in soft.items s none, right? We say we didn't get anything, don't advance the state. None of these things matched. None of these things matched. So last error now no longer matters because if we hit an error, so errors just get ignored in this any block, and this is a problem. And this is we kind of wipe some errors off the map here, and that can be bad. But we're just gonna do this. We're gonna do continue. Actually, we can just say unit, right? We can just say unit. There's nothing there. Item run s.clone. Cool. So we ignore errors, we keep going until we find something. If we get nothing, we just give back none. Let's build this, and it's going to yell at me for a bunch of reasons. Expected f enclosure found f. Required f to implement parser ste. F is a function from s to t. Hold on. F is a function from s to... from s to... Wait, what am I saying? 6. No? Sequence? Any. What's this? Line 42. Binlang parse. Oh yeah, parser STF. F result STE. Where F 36. Where F is a parser. That's fine though, right? Because F is a parser STE. Any STEF. EF. Parse this. Where F is a parser. Sorry. I complicated my types. That's fine. So F is just a parser, it returns a t, but any implements parser s option t because it either returns a thing or it returns nothing. Now, 51 result st. Yep, that is because I can't type properly. Can't use my eyes properly. Found this type parameter expected. Oh yeah. So this is a tuple, right? So we have st. We're going to return okay s sum t. And I think that was not enough parentheses. Excellent. Okay, this is getting better. Now, because we've got any, we need to... So any require. Now we have this type require that takes a parser that's an option and reduces it in with an error that we parse in. So this is good. So now we say require This takes a parser and an error. So we put this error down here. We're going to say parse error new input. Auric, I'm building my own language. Yeah, I'm building my own language, my own compiler, and it compiles down to my own virtual machine with my own bespoke instruction set. This is Tom Marks all the way down. And I have some regrets, but it's fun. I'm learning a lot as I do it. So this is going to be a parse error. What error is this? Expected bin op. We expected a binary operation. We did not get one. This should be the thing that closes require, which should go, should go here. There we go. Okay, then this closes the map here. Nice. Okay, this is a bit messy. So that require gets closed, then we have a parse error, and then we do the map part of the mapping. Except this should probably be indented one more. God, these are a little bit tricky to read. And then we're going to do this. I think that makes it easier to read. Okay, so now if we build. Never quite wrap your head around parser generator types. They're just functions. There's no magic. My generics look a little bit messy, but the idea is, this is a much simpler example. We have a function called expression variable. It takes in the current state of whatever we're parsing, and it gives back either the new state. So in this case, it's just a string slice. There's no magic. If you have foo bar and we parse out foo, here you would give back bar, right? It's just whatever's left after we've done the parsing and the thing that we've parsed. So in this case, expression variable, we just grab a thing that could be a variable name out, in other words, an identifier, and then we have this fancy map combinator. And this is why it's cool that they're just functions, because this just has this signature as well, but it returns a string instead of an expression. Then we have a function called map, which can take the thing inside of the result and map it to something else, but all of the errors still propagate up the way you'd expect. That probably wasn't the clearest explanation, it probably didn't help anything, but it makes me feel better as a streamer that I have made an effort to address your question. I guess the thing I want to drive home is there is no magic. They're just functions. Now, if we look at how the map function is defined, it's a fucking nightmare because you've got all these generic types. But all this is doing is taking in an f that is a parser STE, and all parser STE is something with this shape, right? Something that takes an S and gives us back a result STE, where state is our state, so our string of the code file we're parsing, T is the thing we're pulling out of it, and E is potentially an error. So all map does is take a normal parser, which can be a function that takes a stir slice and gives us back the result stir slice whatever error, and a function from T to U, and it takes us from a parser of STE to a parser of SUE. Right? It maps inside of the parser. It lets us transform the thing we're parsing. But again, because there's no magic here, they're just functions. So we can pass any function into this. We don't have to do much work. Yeah, awesome. I hope you genuinely mean this and you're not humoring me. But I hope that was a useful explanation, right? The most important thing about parser combinators, the reason that I've been using parser combinators and the reason that I was drawn to writing them myself for this project is because they're really so simple. If I was using a language, I still would have had to write all of these functions in this file. The only thing it would have saved me was this file and doing this nonsense, right? This is all I would have gotten from a parser combinator library. All I had to do was write this myself, and I think in doing so, I actually learnt some stuff about Rust. So that was good. I feel good about it. Cool, Bobbius, you do actually see what's going on with generics. Excellent, excellent. Like, if you've done a bit of Rust, if you've done a bit of Haskell, if you've done these languages, it probably isn't too unfamiliar. Excellent, excellent. Cool, okay, so, where was I? I lost my train of thought a little. We're doing this parser error stuff. Oh yeah, I forgot. I've got a new error variant to add, which is expected binop. And that's going to be like expected type, except expected binary operator, which is, for example, a plus or a multiply, or a greater than equal. Okay, now what's the next error? The next error is I still can't type. There is no surprise here. Okay. Results to, yeah, so we have this issue with any again, so we're just gonna wrap a require around this. And this require, we need to give it an error as well, so we're gonna say AST, no we're not, we're gonna say parse error new, we're gonna take the input in the current state, and we're gonna say parse error kind expression. Because we expected an expression and we didn't get one. Here we're gonna say the same thing. Do I care? Do I care? Do I care that these are two different functions and I'm gonna return the same error variant? Maybe I should. Maybe I should split this into two things. It really can't hurt. So this is an expression, LHS, and maybe for now they behave the same way. Expected binop expression. Cool. Oh, this is also binop. Okay, expected expression. Expression. Cool. And the reason there's this distinction is complicated and silly, but it just stops us getting stuck in an infinite loop trying to do this parser combinator stuff. Because if we try and parse a binary operation expression that has a left-hand side and a right-hand side, but if we try and parse both of those sides as another binary operation, we can actually get stuck going forever. So we just say that the left-hand side of an expression can't be a binary operation, but you can still chain them forever. This doesn't really matter. But also the right-hand side of an expression can also be the same as the left-hand side of an expression. It's a fun little quirk of this. Okay. We don't have enough. We have too many. We have too many parentheses. This is like the opposite problem. Usually I run out. I have too few. Parse error kind expression. Expected. Maybe expected is just kind of a given here. I don't know. I feel like this may be a little too verbose. We're running out of errors. This is good. This is good. We have another any on line 117, so we're just going to say require. And what do we have here? Well, we have parse error new input parse error kind expected statement. Now, this does erase any error inside of this any. So I think what we're going to have to do is write a smarter any function that understands the parse error type. We're not going to do this immediately, but I think that's what we're going to have to do eventually. Let me just search for any future instances of any. Require. We're going to wrap this in a require. And again, we're going to hit this error, this issue where this any erases any lower level errors, so we're actually going to lose a lot of the work we've just done. But that's okay. That is okay. Okay. Parse error new. We take the input and we say parse error kind top. Cool. So expected statement, expected top level. It almost feels like we have two layers of error here that maybe are not actually the same thing. But I don't know. Maybe they also kind of are. Expected statement. All right, what do we get now? We're down to the home stretch. Run parser. Excellent. So map this is all we got to do. We turn it into a string so that we can print it out. Okay, expected function definition, and instead we got the entire file. Wonderful, wonderful. In this case, actually, we can do better. We can do much, much better. We can do way better, because we should be using the current state instead of the input. Does this build? Yes. Does this run? Yes. Does this give us a meaningful error? No. Cool. Cool. So this seems to think that this whole file is just irredeemably broken. Well, that's good. So it does parse. That does raise questions, though, because we expect this to not... We expect this to print out the place where this is occurring, right? But if we look at this, Okay, I've got a thought. What is going on here? Current state is input. Oh, hold on. No, yeah, that's fine. Oh, wait. I see what's happened. Because I'm constructing this up front so I don't do the allocation. What I actually need is when I run this down here, it needs to be a require any. This is where we wrap up the extra context. So we're going to put this here. Yes, excellent. Correct. This is the correct way to do it. Require. Okay. Value moved here. Okay, here's what we're gonna do. I've got a solution to this problem. And that is, stop trying to be clever, stop prematurely optimizing, just bang this here where it belongs. Then we don't have to worry about anything. Now when we run this, it tells us that there's a problem with the function definition at the point that the function actually blows up. Wonderful. Now, let's write a new combinator. We're going to go in here and we're going to call this, we're going to copy and paste error, right? But it's going to be a little bit different. We're going to copy paste any, sorry, but it's going to behave a little bit differently to any. We're going to say any collect error, where any collect error, yep, it all behaves the same. Except it's going to collect the errors of the things underneath it. So this probably needs to be clone. Parser STE, parser S. We're still going to have an option here, but we're going to say vec. It's going to return a vec of errors. Okay, so instead of just giving back, actually this is kind of hard. I guess it needs to give back. I guess T in this case. I guess it's like this, right? We're going to give back a vec of errors. We're always going to give back a vec of errors. And maybe a T. I guess we don't have a T to give back if we haven't parsed anything. Okay, so let out equal let vec new. S none as. Actually, no, hold on. That's not right at all. That makes absolutely no sense. We're either going to give back... We're going to give back an option T or a vec of E. We're not let's not get too complicated here. SD vec of E. Okay? Except now in this case, we're gonna say ers. Okay? This wraps up the problem with needing a default value for E. We don't need that anymore because vec, you know, kind of empty vec is the default value. And now if this is an error, we're gonna say ers.push E.clone, probably. Actually, let's just try ers.push E. Let's try it without the clone. Okay, so if I build this, does it yell at me? Yes. Run, pass back option. This needs to be mutable. We're gonna keep this as returning an option t so that it remains compatible with the main any type. For any, we also need to change this name, collect error. Okay, excellent, excellent. So now we're going to come in here, and where we have any before, we're going to have any collect error. Excellent. Now we're going to see the error types. Okay, that doesn't quite work. We're almost here, we're almost here. Set of vec. Oh, it still doesn't work with require, does it? Because, does it? Require, it won't work with require. Okay. Accepted pass error because of this. We got, yes. Yes. Okay. So we need a case for pub from. We need a case for where we've got a vec of errors. We want to turn it into just one of these errors, if possible. Right? We want to be able to do this. And so we probably need some kind of error kind that represents a list. Now this could break some other stuff. We'll say kind, parse, error, errors. We're just going to have a variety of errors, okay? And let's even make it very, very simple. We'll say self errors v. Self.v.iter.map self.v.join. Let's just do something really basic for now. How does that look? Cool. This is good. This is good. We're gonna map we're gonna map error into parse error new current state, and we're gonna, oh no, hold on, wait, we don't need to do this. We don't need to, it's not new, it's from current state and the vec of errors. Nice. Here the type of out is inferred to be vec top level, found option top level. Okay, so we're gonna go back into our combinator and we're gonna stop being stupid. This isn't an option t, this is just a t. These any and any collect error, they're incompatible. They are fundamentally incompatible. So let's just simplify everything. This is better, this is better. Associated item errors not found in this struct. Not found in the struct because it's the parse error kind. Partial EQ. Okay, so partial EQ, it's gone. It's out the window. It's good to start with these things because then, you know, the compiler yells at you when they stop working. You can evaluate it. Oops, and this isn't self. This is just v. v.join, v.iter.join. Is that it? Method join is available on iter parse error. V. Is it this? Straight bounds join, not satisfied. No? No? What's wrong? What's wrong here? Iter dot map x dot to string. Can I do this? Iter join is available. Join not found for iter. Okay, that works. I think I did some unnecessary stuff there, but that's okay. Expected statement if blah blah blah. Okay, so expected statement, we don't get a statement. Return fib blah blah blah. I don't know what this means. I don't know what this means. What if we do this? What if we do this? What if we say, we do them all on new lines. So we join with a new line. Maybe a new line and then like 2 hashes. I don't know. And can we print this out as an actual thing? That would be nice. So we don't end up with this weird new line soup. Expected statement at, so expected a statement here. New line return blah blah blah. That's good. Look, I mean this feels better. This feels better. It's definitely better. It's not perfect, but it's definitely better. Function definition. Okay, because we only expect one thing, right? Function definition. So the problem is when we look for a statement, the statement comes down here. So we're looking for a statement at the very start of this thing. So we just fail to parse this as a statement. That's good. That's good. This is a lot better than just falling over with no meaningful message. And then I was having to play like, you know, guess where this error was in these 2 functions. It actually tells me the function it's in now, and it tells me that it fails to pass this as a statement. I knew that before, but now I really, really know it with a lot more confidence. Now, it would be great if I had statement at here, blah, 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 at int fib I. Yeah, okay, cool. So it's saying that it expected a statement here and that happened in this function definition, which is wonderful. That's really, really wonderful. Bobbius, thank you for the refollow. I really appreciate it. Please don't continue to make new accounts, otherwise I will get banned for follow botting. But no, this is a genuine new account. I appreciate it. You are insignificantly padding my statistics. Okay, so what do I do about this? Well, there's another any in here that's kind of hiding what's going wrong, right? This any. So what if I turn this into an any collect and I get rid of the require? Any new, this is good, so we run input, right? Yeah. Run input, but then we map into this vector of errors. We do some stuff with it. We do some stuff. Dot from parse error kind error. No, we don't give it a parse error kind. We just give it the vector of errors. Does this work? It does. So now we're going to hopefully get even more context, and it does. So we get expected token here, expected token there. So not all of these are going to be valid ways to parse, right? We're going to try all of these things, and we're going to try them in order. If assign declare return. If assign declare return. Expected token return at if. So we don't get if. So we can see, you know, we see what these things are trying to do. So it's looking for this token and it doesn't find it. It's looking for this and it doesn't find it. But we see in this case where it's trying to do the if statement parsing, we get all the way to this unexpected token. We see that we're looking for unexpected token. We find a parentheses when we're looking for a close bracket. Okay, I need to go into, where is it, token. Characters, token. I'm going to get rid of this. I'm going to get rid of this slice. I'll comment it out for now, but I just want all of input. That gives me more context about where this actually happens. Okay, this is nicer. Expected token here at less than equal to 1. So, it's looking for a close bracket, and it's found, I see what's happened. I see what has happened, okay? So inside of the condition block of an if statement, let me draw this. I think that'd be nice, right? Draw a picture. A picture paints 1,000 words. Inside, so we have if cond, then we have statements, and then it ends, right? And then we maybe have an else. ... Whatever, we're going to pretend else doesn't exist right now, okay? So what happens in this condition block, this condition thing? Well, right now, we have this thing where we have I less than or equal to 5 or whatever. When it tries to parse this, it first looks here, and it says, hey, this is a valid identifier. So it says, okay, I'm done. That's it, I found a valid identifier. Check. So this is now our expression. So then you keep going to finish the if statement. What comes after the expression in the block? We look for the close bracket, which doesn't match here. So what we need to do is make sure that we're always consuming the longer expression first. We always need to try and consume the binary op expression before the shorter plain variable expression. And we can do this. We need to look at, in language, expression call, expression. Where are our expressions? Expression LHS, so just expression. Interestingly, this should come first. Where's that if statement? Statement if, we get statement terminated. Statement terminated should be statement if, yeah, if. So we're in an if, statement if, token if, expression wrapped in these things. Why does our binary op not succeed? Why does that binary op not succeed? Expression bin op. So we look for the left-hand side of an expression, which we find. Then we look for... So why does this fail? Why does this fail? Because what we're seeing here should actually be... Okay, this is a lot. There's a lot of stuff going on. Oh, can't see code, can't see code. Thank you, thank you. I always forget this. This is the problem with drawing. This is the problem with drawing. I always forget this. Thank you very much. But yeah, Bobius has it. Greedy matching is the problem. The order of these things is a problem, but it shouldn't be. We should be matching against this. We should be matching against this. So this is one of the places where, you know, we do start to see problems, cracks emerge. Okay. So. Let's think about this. Let's go into our error type. And let's say, let's give every parse error a name, or something else in the context, right? Let's give it a thing, an identifier, a tag. Maybe a tag? Maybe like a, maybe. Then we're going to do something really silly, and we're going to say tag, and we're going to take a mutable reference to ourself, and we're going to give back a self, but we're just going to say self.tag equals, well, we need the thing as well. Sum s.toOwned. Right. We're going to do this modifying mutate, which is hopefully going to make this a little easier. So we can just say tag. right? Like this. Self missing tag. Cool. Now when we print this out, we can say if let sum tag equals self.tag. Right, so just the option to wrap a little bit more context into this. Excellent. So, my expected token. Does this actually show up anywhere? Maybe not. Let's just wrap it in something obvious so we can see if it actually pops up. Maybe it doesn't. That's okay. Maybe this all just gets just chomped out of existence. Expression, tag, require, skip white space, expression. This should happen. This should be somewhere. We'll find out. We'll find out in a second. We're just gonna chuck a couple of tags on things and see if that helps. Statement. Parse error from errors, tag. Oh yeah, here it is, here. So there is in fact, yeah, so we can see that following this big blob of things, this is our like statement parse block. I need better formatting here. I really need better formatting here. And maybe it's better if I come in, where is this? Here. What's a good way to handle, what's a good way to format this error better? I don't know. Yeah, like this, right? Error message text, blah, blah, blah. Revert if let any custom error new type and trade is going to more boilerplate. Reducing item minimal code examples, not to move. Okay, yeah, excellent. Custom error formatting, return Rust main, simple scripts test programs. Yeah, okay. Okay. Real programs don't necessarily do this in main. That makes sense. That makes sense. Let's do it smarter then. Let's say if let's go match run parser. We'll just print everything out. We'll do this. And here we just do everything we were doing before. Just like this. Wonderful. Cool. Okay, this looks a little nicer now, even if it's a bit weird. Okay, so it would be nice to indent these or something maybe. Lerny Wenzi, what font do I use? I think this is Deja Vu Sans Mono. Let me double check for you right now. It's in st config.h. Actually, wait, no, hold on. This isn't the terminal I'm using. Yeah, Deja Vu Sans Mono in this terminal. It's a cool font. I recommend it. Highly recommend. Very legible. I picked it for a stream font because I think it reads very, very well. Okay, so foo, these error messages are still it's still extremely janky, but we're gonna roll with it. Bobbia says I have the perfect font size for reading on stream. Thank you. I spent a lot of time experimenting with this, and it means a lot to hear that people appreciate that work. I think a lot of streamers have very small fonts, and I don't like that. I want everyone to be able to read what I'm doing. Okay, so now, can I write a really stupid combinator called tag which is gonna take, it's gonna take a stef, where f is going to be a parser, and it's going to give back a function that takes an s and gives us back a result ste, because every function with this signature implements parser, where f is parser ste, except our error is going to be a parse error. Nice. Legitimately prefer a small font when working. Some things you do need a smaller font for. Sometimes you want to see more code on screen. Again, because I'm doing these personal projects that are, less than 10,000 lines of code, it's not such a big deal that I can't see so much. And because I've written all of this, if I'm in the workplace, sometimes you do need to see more on screen. Okay, so we have a parser error. So what we're going to say is match f dot, we're going to say move input. Then we're going to say match f.run input. If it's an error, then we're going to give back e.tag. We need to take the tag as well. And we're just going to copy it. Otherwise, we return x. Right? Does that sound good? Yeah, because that's just the result. Okay. Does that... Okay. something has gone wrong. E. Because I had too many generics. Tag not found for this type parameter. E.tag not found for parse error. Parse error. It does have a function called... Oh, hold on. That's because I've set this up as a generic, when in fact it should just be a type. Beautiful, beautiful. Tag.to... Oh, that's even better. Now I'm not sure if this is going to work. It does. Beautiful, beautiful. Okay, so now I come into statement, and I don't have to modify the inner functions. I can just say tag statement if, and I can give it this, statement if. And this will just work. There's not going to be any errors, right? Because there's never any errors the first time you do anything. Expected string found stir. Now, I think I can actually make this just a stir. It's probably going to yell at me about lifetimes now. Yeah. That's okay. That's okay. Do lifetimes like this have to come first? Tag. It's just tag. And then I think this is just a plus a, right? Do lifetimes have to come first? Yeah, lifetimes have to come first. It's a really arbitrary rule, but I guess you gotta have something, right? You gotta have some rules. F must be available to a lifetime of a, so that f, where f is a parser plus a. Expected a fn item, found a different item. Expected fn item for LA, function A, result A, statement if. How the return type of this function. Is that because I put this here by mistake? No. Yes, that does need to be there. Okay, so I suspect that this lifetime somehow blows up everything. Levendu, thank you very much for the follow. Welcome. I hope you enjoy compilers and Rust and weird 16-bit virtual machines and rambling and all the other fantastic things that this stream is all about. Oh my gosh, is it 4:30 already? I've got to go to a chemist at some point today, unfortunately. So I might have to do that soon, unfortunately. Should have started streaming earlier. I always run into this problem at the moment. Expected function item found a different function item. So what is wrong here? What is wrong here? For all a statement. The return type of this call is parser statement. Due to the return type of the argument passed. Due to the return type of the return type of this call is for all a stir. Yes, this looks correct. Due to this argument influences the return type of tag. This argument influences the return type. What the hell? Let me try something. Let me try something really crazy right now. Okay. Where we're just gonna be generic on the return type, right? So we're gonna stir. Now, actually, we have two lifetimes at play here, right? We have the lifetime that this needs to trap. And I don't think this really... I think this is what we need. I think this is what we need. And now this is just a stir ref. And this is a stir ref. I think this works now. I think this works now. F must be up to the lifetime of B. Yes, okay. That's okay. So, wait, why does F need to be valid for the lifetime of B, though? I don't understand. So, prototype F must be valid for the lifetime of B, but why? Why does F depend on B? Because B, like B and F, these things never interact. These two lifetimes never interact. I don't understand how this has happened. I'm going to try this, but I suspect this will still be angry at me. Yeah, because of this error. So why has this happened? Mismatched types. Expected a function item, found a different function item. Mismatched types. Yeah, probably because these lifetimes don't interact, right? We have an A stir and we have a B stir, but why? Okay, do you know what I'm going to do? Do you know what I'm going to do? Like, seriously, I can't be bothered. I can't deal with this. I'm just going to make it a string. And I'm going to accept that we do this really stupid copy, but I can't work out the lifetimes. And if you can't work out the lifetimes, just do a stupid copy. I don't see what the problem is. Okay, so now if I make B, it's just going to yell at us because... okay, so we do actually still need to be explicit about this. That kind of makes sense, I guess. That kind of makes sense. And now we have, yeah, now we have this. So to string. I would love to fix this. If anyone knows what's gone wrong here, please let me know. Holy crap, that's very upsetting. Very upsetting. Silly, silly borrow check. Oh no, it's the same error. It's the same error. Expected a function item, found a different function item. Have I forgotten a word? Like what have I done wrong here? How have I done this so wrong? How have I done this so wrong? Yeah, things get weird with functions generics, but all of my, well, I think it is a lifetime thing because I'm doing this, like I'm already passing a bunch of functions around. I've got this like type def that works. I think, so for example, let me do this, right? Let me see if I can do this. Because like kind of, I thought it worked before when I was being even more generic, right? When there was no lifetime in the signature. I think, because lifetimes are part of the function signature. Oh no, it's the same problem. Okay, maybe you're right. Maybe you're right. But I'm doing this kind of thing elsewhere. Okay, do you know what else I can do? I'm actually overcomplicating this. I'm really overcomplicating this. What if I just... Wait, no, that's not right though. Let's... Bugger. Okay, no, yeah, hold on. Let's do this dumber version of this function. So let's go tag where we're gonna have input stir, and we're gonna give back an impl function which takes a stir, and it's gonna give us back a stir. It's gonna give us back a t. It's gonna be generic over t, and it's gonna give a parse. End of line 9. No, because the where statement, the where clause is part of the generic bullshit that's happening in the function declaration. This is the start of the function body. But good pickup. Good pickup. How's your programming going? Have you finished uni now? I don't know. I can't believe how many years it's been since like BAM 2018 and stuff. It's kind of crazy. I think you finished uni, right? You're working? Got a programming job? Okay, so input. Oh wait, no, sorry. So we've already done the part where we take in the thing. So we're gonna say, wait, no, this still isn't right though, is it? I'm missing the parser part of this. So we still have an f, where f is a parser which takes a stir and a t. Oh, internship at Riot Games in Sydney. That's really exciting. Yeah, that's so cool. You could work on Valorant. You'll know they'll have really good support for low sensitivity, right? You'll be you'll be making sure that the mouse handling is really good. So that someone playing on like 1.5 meters per 360 can still thrive in a competitive environment. That's a really specific reference to the Australian Quake community. And Knight doesn't even he was one of those players. He needed an entire desk to do a 360, and he doesn't even play with a low sensitivity anymore. But yeah, never stop thinking about watching him just how much he moved his arm to play. Yeah, working on Valorant, and surely being a top-rated FPS player in a game in Australia, surely that's a credential. How many people have a credential like that? You've pushed around Python. You've locked horns with some of the Aussie Quake legends. Okay, so why is this different? Why is this going to be different? Well, this is going to be different because we can say f.run input. This is the same level of generic bullshit, but I'm just hoping that it'll be a little simpler. So we'll say let sn, we'll say match f.run input. If we get an error e, we'll say error e.tag. But this is stupid. I don't know. Okay, no, this doesn't work. This function signature is too dumb. It's too dumb. I can't do it. I can't do this. I'm gonna have to do this a stupider way, which I wanted to avoid, but that's okay. Can I just undo everything from the last This is why more regular git commits are good, because then you can just... Yeah, there we go. Okay. We got rid of it. Is this built? I don't know. I don't know what I did. I don't know what hole I dug myself into then. Statement. So statement if we want to say... but we want to wrap it here in all these places. Am I building an IR along with the parser or just the parser? I'm doing code gen directly into my virtual machine language. So I'm literally just writing instructions. My whole code gen is 400 lines of code right now, and it's a little bit simplistic. It does a lot of things through the stack. I will be smarter about this at some point and use registers more, but right now I'm just doing the simplest possible thing to get a compiler running on my machine. and then I will think about how to make it smarter. I don't know how much I want to invest in this language, or if I want to use this as a springboard to writing a compiler that runs on the virtual machine. I think that would be kind of cool, but the fact it's 16-bit might be a little limiting. I built the machine as well. Yeah, this is me all the way down to the metal. All the way down to the metal. It doesn't do loads yet, but it kind of works. You can actually play around with the machine on my website. There's just very little documentation about it, but it's out there. It's out there. It's very hard to write for because, hold on. I really should have like a bot that does this. It is here, the language stuff. I haven't actually pushed any of it yet. I've only been working on it for like a week, maybe a little longer. So I need to do a push. I've got like a local git that I haven't pushed to the main repo yet. But yeah, it's out there. You can have a look. You can poke it. You can prod it. You can let me know if my VM instruction set design is fatally flawed somehow, because that would be good to find out sooner rather than later. I really need to wrap this out here. I really need to wrap it out here. So I don't understand. Okay. I'm going to try this again. I'm going to try this again. I'm going to try this again, and I'm going to see what errors I get as I go. Okay, so there's no function called tag error. So we're going to write a function. It's going to be called tag error. It's going to take a parser, which is a st, and a parse error. It's going to give us back a result, st parse error. I'm just going to do something very simple. We're going to say p.run. We're going to say move. No, it isn't. Sorry, it's going to give us back a function that does this. We're going to make a closure, and we're just going to give back whatever this is. Now, does this work? Let's not even do the other argument. Does this work? S. We need some generic parameters. So st. P doesn't have its sign node. Impl. Okay, here we go. Here we go. Expected opaque type found function item. Statement variable assign. So statement variable assign takes an input function st. But like this whole library, all of this code I've written is based on this idea of being able to wrap these up, right? Because, for example, I could say map, right? Maybe this is what I need. Maybe I can say map. I can do this. Or not. Okay, so I've got some functions that don't play nice with my parser combinators. Now that's unexpected. The problem might actually be with this function, right? What's going on? Statement variable assign. Fake type. Function. What is this? Why is the problem with this? Okay, so if I just have this, right? That compiles, but it yells at me. If I just have this, that compiles, but it yells at me. But if I mix the two somehow, the expected closure. Why are these two lines related like this? Expected opaque type. Statement yeah, compiler not pushed as of now. I'll do it after this stream. Once I do this better error handling stuff, I'll push something. So, okay. Now what does it say? Statement if. Okay. So the problem might be, maybe the problem is putting these things in a vec together rather than anything more specific, anything more like highlight. I think the problem here is the vec. I think that's what I've arrived at. I think that's the conclusion I'm rapidly coming to. So in that case, God, How do I do this? How do I nicely do this? It would just be really nice to be able to say, hey, we're trying the if statement here. We're trying the... Okay, that's okay. I'll just have to do it manually. So we get this beautiful output, right? And we can see, oh yeah, but yeah, so this is how I got here. It is being greedy. So it finds, when it's doing this binary operation, it just accepts that the expression is done once it finds a variable. So we should really be looking at expressions. Expression, literal expression. So this is what's succeeding, but we should be trying this first. Why does expression binop fail? Well, expression binop, and the annoying thing about this is expression binop actually doesn't fail. So let's write a test, actually. Let's write a test that is very specific about what is happening here. Let's literally exactly what is in this file, right? So if I less than or equal to 1, if I make t, let's get rid of tagger, that's dead. Car found option car. Test any. Okay. Okay, so this test fails in the same way the other one does. We've arrived at a sane way to test this. I fell down a 20-minute rabbit hole then, but we've arrived at a safe and sensible way to play around with what's going on. So this is good. This is good. So, it's always good, right? When something's being weird, to find a simple example. Statement if. And it's when we're looking for this closing expression. We somehow successfully parse a binary operator. Expression binop. It looks for an expression LHS, then it skips white space, then it looks for an expression from S1. So we're correctly advancing. That's also worth checking. I guess the other thing that would be kind of interesting here is, so if we're in an if statement, wrapped, we can't really grab this out, can we? It's all layered, it's all deep, it's all deep inside other stuff. Is my progress in the VODs? Almost all of the virtual machine build is in the VOD, but most of the compiler work has been offline because I started writing it on a plane, and I thought I'd just keep going. I was going to do it all on stream. I'm actually recording everything I do in Askinema, and I'm going to make a YouTube video talking about the theory of parser combinators and how I've approached doing really, really dumb code gen, and just how I've kind of incrementally built a language from the stupidest possible solutions to problems. So yeah, I want to do a bit more of a structured video about it. I want to give a talk at my local Rust meetup about how I've written parser combinators. I think that would be fun, but unfortunately a lot of this work has been off stream just due to the facts of life. But yeah, keep your eyes peeled if you're interested in a kind of lecture style video where I talk about how I got here. I haven't, I'm hoping to do some videos. I've been saying it for a while, but I think this is a really good thing that I understand enough to talk about, but also I have a lot to learn. I can talk about the problems I've faced, how I've solved them. It would be good. I think that would be fun. I think that would be a cool thing, and hopefully lots and lots of people will watch it, and I'll make lots of money. The dream. I honestly don't know if that is a dream. It might be a nightmare. Okay. Oh boy, you're familiar with the compiler, how I created my architecture. I mean, I just sketched it on an A5 piece of paper one night and then built it in a live stream. Like, I don't really talk much about how I arrived at the instructions necessarily, but give the VODs a look. Let me link my VOD channel. It's actually, is this all on my VOD channel? I think it is. Yeah, okay, cool. So it's all on my VOD channel. It's here. You can follow it through, and a bunch of other random shit I've been working on here. But yeah, thanks for stopping in and showing interest. It does really mean a lot to me. And thanks everyone watching. We're getting a nice little viewer base here. I enjoy it. I should do some longer streams more often, apparently. That would be the way to go. Okay. expression. So I'm going to go into my binary operator parser. And I'm going to say, I'm going to do the only thing I know how to do in this situation, which is dump a couple of printlns in. Binop expr0. Okay, this is all I know how to do. I could debug this, but I think this is actually going to be easier. Okay, so what do we get? Expression 0, so I less than compile error. Okay, so we're never hitting the second part of the expression. So this is a problem. This is an issue with our expression parser. So actually, maybe what we need is... maybe we need this. Maybe we just need to say I less than or equal to 1, right? Let's go really, really simple. And we're going to have expression binop okay, so this fails as well. This fails as well. Context, yeah. Unwrap and op less than. Okay, 234. I actually don't know where that blew up. I don't know where that blew up. Where are these errors? Test conditions, less than. Okay, so expected expression, and we got equals 1. Oh, I see what's happened. JCast, thank you very much for following. Thank you for, your interest and your follow. I really appreciate it. It means a lot. I see what has happened. Okay, let me put that up on screen again, because this is a very instructive thing, and this is something you run into with parser combinators. Where was that error? Where was that error? Okay, so this is why these new errors are really good, right? We're unwrapping on an error, context equals 1. Cult 0, not quite. I'm going to finish this off, but I am going to have to run to the chemist soon-ish. You're going to see me do work. You're going to see me do work, I promise. I promise. I'm going to do it for you. I'm going to keep pushing through. Okay, equals 1. Equals 1. So why are we trying to pass this as an expression rather than just 1? Well, if we look at binop, wherever we actually pass our binary operators, we try to pass less than before less than equal, or greater than before greater than equal, less than before less than equal, right? So what that means is we're gonna, if we find a greater than or a less than sign, we stop, and then we're left with the equal. So order is important, and this is so critical with how I've defined these parser combinators. You always have to look for the biggest thing first, right? If A and B are both valid, but A is a substring of B, you have to look for B first. Or A is like a, what do you call it when a substring comes at the, is it like I don't know what I'd call that. I don't know what I would call that. Okay, so now our tests pass, and now we're close. We're getting closer. I'm just going to go and get rid of these horrible printlns. And the printlns actually didn't do much, right? What helped there was writing a good test. Okay, expected a thing at... Now, this is interesting. The way I've defined my language is that every statement ends in a semicolon. So we need to do this. And now we've finally parsed everything, started compiling everything, and arrived at our next problem, which is that I have not implemented the less than or equal to binary operator. Okay, so source bin lang better, let's say different error reporting, because it's still pretty rough, but it's it's different. I missed a double quote, which is really weird. I don't know how that happens so often. Okay, excellent. So now everything is starting to come together. If we go into our code generator, unimplemented bin op. Okay, so let's see if we can implement a new bin op. Bin op than equal. And this is going to require a little bit more. Out append. It's going to require a little bit more code. Now, doing this via a vec is a bit stupid, but it's okay. It's okay. We're going to just wear this for now. So we need to do a few things. We have the two things we want to compare on the stack. So we need to pop these out into registers. We're going to use registers B and C for now, because they're the ones that we tend to clobber. So we're going to grab an instruction. It would be great to have a DSL for writing inline assembly better, but we're not there yet. So we're going to pop... we're gonna pop into B from the stack, pop, and we're gonna pop into C from the stack. I don't know what is going on with the indentation, but I'll let Rust format handle this. Okay, so now we need another instruction. It's going to be instruction test. I'm going to remind myself what my test instruction looks like. R1, perfect, perfect. It's just two registers, so in this case it's going to be register B, register C, and it's going to be the test op LTE. Excellent. Now, and this is going to set the compare flag. So we're going to say, what do we say? Unsave. Yeah, so the only thing we have that handles, let's say add if. It takes two registers, annoyingly. Let's add a new instruction. Actually, wait, no, there's an offset. Get register on 2 times offset value. Plus 2 times offset value. Now if this wasn't 2 times, that would be... Actually, is that okay? Can we? Okay, no, whoa. We can do this. We can do this in a really jank way, but we can do it. We can say, let me copy and paste this again because it's a lot of typing. I'm about to do some horrible things. I'm about to do some awful, horrible coding, okay? But the way my virtual machine works, the only instruction we have to read the result of a test instruction, right? Test compares two things in some way. In this case, we're doing less than equal. If it succeeds, it sets a flag, and then when you call add if, it reads that flag. If that flag's set, it will add 2 registers together. In this case, we're going to target register C, we're going to add 0 to it, but we're going to add 0 plus, this gets multiplied by 2 for complicated reasons, but we're going to add 2 to register C if this comparison succeeded. But before we do that, we need to 0 out register C. Maybe. Actually, R0. No, we don't. This sets register C to 0 plus 1 times 2, which is 2. So this sets C to a truthy value if the previous comparison succeeded. Now we can push C onto the stack. This is a bit stupid. If you're looking at this and you're like, wow, this is a bit stupid, you'd honestly be correct. You would honestly just be correct. So that begs the question, like, why am I doing it like this? Well, it's a very good question. I'm doing it like this because, wait, why are there so many? That's the correct, okay. I'm doing it like this because this add if instruction is actually really, really powerful. It's a really powerful concept, and it lets us do a lot of different stuff. At some point, I'm going to be smarter about where these come from and where these go. Like when there's potential for us to get the things that we're comparing from registers rather than the stack, this will get a lot more efficient. When we're open to the possibility of returning this value off of the a register rather than having to push it to the stack, this gets a lot more efficient. But for now, we just end up with this garbage soup, and let's see what happens when we build it. Unresolved instruction 0 found. Oh, yeah, that's really funny. I didn't realize I was like double dipping with my push there. Okay, with my instructions there. Okay, expected a thing. Oh yeah, so these just need to be semicolons instead of things. Nice. Okay, so now, oops. Unimplemented bin op subtract. That's fine. That is also fine. We can do with subtract. And we'd have a stack native operation for this. We've got this little like stack instruction that can do a bunch of different stack stuff. It can lead to janky ways of doing basic operations at time. Exactly. This is desirable for an instruction set you're compiling to, but not desirable for an instruction set that you are writing by hand. And that's fine. That is stack subtract. That is a trade-off that I gladly accept. Okay, this is good. This is good. So now we're gonna disassemble this, and we get all this stuff. This, hopefully, I'm gonna run this, and I'm gonna get the 5th Fibonacci number in the A register. That's the goal. That's what I'm hoping is about to happen here. So let's xclip selection C. So we've copied this. Let me pull up Python. I've just got to run my http.server. I forgot to run this before, so let's jump over to localhost. Okay, beautiful. We paste our program in, we compile it, we run it, and it blows up because we have an unknown opcode. Because I don't know why. Okay, we've jumped into a garbage part of memory. That's okay. That is okay. Let me just copy and paste again. Reset, compile, run. We end up in the same place. Okay, reset, compile, step. Now we're gonna step through. We're gonna very carefully step through here. And maybe recursion just is not right. And actually, let's just do something really quickly to, oops, see what happens. Oh, that's why there were so many HTML files when I did clock before. That's cool. Oops, I've lost chat. I've lost my chat. There it is. Okay, good. Okay, so. What is going on? What is going on? Test.code. Let's just do something. Let's do something silly, right? This is not correct. This is no longer correct behavior, but it's gonna let us see what's going on here. And so what's going on here is more fundamental than recursion. So that's good. That's really good news. So when does this happen? Step. So 66, 68, 70. So we're trying to return from a function here. Test less than equal. Okay, here we go. So test less than equal. What happens? Add if C0, 1. So C ends up with 1 in it, which is good. We push C to the stack. We pop C. Oh yeah, because we push C to the stack, and then the first thing we do, continuing to evaluate this expression, is to pop it from the stack. We test to see if it's 0, otherwise we're going to jump on PC81. 83 SP. So we're setting the stack pointer. Wait. 85, 83, 85 SP. That doesn't seem right. That doesn't seem right at all. What? Okay, this isn't a real instruction. Indeed, we've ended up at a bad memory address, right? We should not be able to do this. This should be an error. I think I know why this isn't an error, and that's not today's problem. I need to zoom in more a bit here as well, right? People were telling me earlier how good and big everything was, and now I'm doing like freaking programming for ants here. Okay, so I realize what's happened. Reset, compile, step. We're gonna step through. We're gonna find where this happens. So it's after we do this test. Add if. So we add 4 to the PC, and that's fine. Immediate PC 81. So this is the problem, right? This should never be odd. So what happens here? What happens here is we're jumping to a label. We're jumping to a label. It would be really cool if we could print these out, right? If we could print this out in a nice way. If we could get every instruction as a nice string. It's hard. It's really, really hard. Yeah, Bobius, you spotted it. You spotted it. PC should not be odd. So this is in our branch if statement. Gosh, this is all very, very messy. Very, very messy. So C, blah, blah, blah. We jump to this label false. Is it possible we're calculating the label address incorrectly, right? Because what was the previous PC? Let me compile step. So blah, 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 70, 80, 81, 82, 84, 86, 88. So we jump, where is it? In PC81. Add if. So they're not both 0. And then we im 88. So it feels like we've missed an offset somewhere, right? It feels like we've missed, we should be offset by like where should we be jumping to? So this is false. Add if. So after the add if, we have the false label. Then, so we're calculating the false label incorrectly because the false label should be 88. It should be 88. What's this? 88, 92. Hold on, how much goes here? Load stack offset C BP3 MP MPCA sensitivity. Your DPI alone isn't enough for sensitivity though. You need 5200 is insane. 400 DPI, you can still do it. You can still pull it off. But you need your in-game sensitivity as well, right? But that sounds very fast. That sounds way too fast. Slow it down. 20 to 30 centimeters for a 360. 20 to 40, I guess, is the comfortable range, the sensible range. Otherwise, you're probably handicapping yourself. That's FPS knowledge guy sneaking out in a coding stream. I should do some Quake-related coding at some point. That would be a good mishmash of my interests. So we don't have an else. We do have an else body, so there is an else body here. But which part's the else body? So what's going on? It's hard to know what's going on, right? It's really hard to know what's going on where we should jump. CBP3. What's it? Stack offset 3. We push C, we pop A. Push C, we pop... so this is the return. So yeah. So this is where... Okay, so this is the true branch. This is the true branch, and this is the false branch from here. This is the false branch, then this is the out point. So we should be jumping to here. FitRioter, you're a compiler for a VM. I'm building a compiler for a VM that I have also built, yes. Don't ask why. You're not allowed to ask why. That's an illegal question. So in other words, okay, so we're at 88. And that's fine. So this is 90, 2, 4, 6, 8, 100. 100. So this is off by 19. So what is 19? Well, it's off by, let's say, 19. Let's say it's off by 20. Well, So if you multiply something by 2. So why is this being calculated incorrectly, right? Some offset. It's not off by enough that I'm like freaking out, but it's off by, well, what's the offset of this function, I guess, is the other thing. MPC, blah, 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 immediate PC, pop, 0, blah, 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 immediate C1, push, test LT. Okay, so here, this is all the functions. So we want to find where we add 0 to the stack size, or load stack offset, immediate C6, C0 PC. Here, yes. So this is the start of the function. So 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 31 times 2 is 62. 63, 64, 65, 66, 62, 64, 6, 8, 72, 4, 6, 8, 82, 4, 6, 88. Yeah, so this is where we are. This is correct. FitWriter, you're in the process of writing an interpreter. That's really cool. Interpreters are cool. Compilers are cool. What kind of language are you interpreting? Is it Lisp-like? Is it C-like? Is it kind of your own thing? Like what direction are you going down? Because everyone has to write a Lisp compiler at some point, or a Lisp interpreter at some point. That's a rite of passage. That's you have to do it. You have to do it. So off by 19, which is a really awkward number. Label false, symbol. So when we offset, so we don't have to worry about the offsets or anything. That's all taken care of for us. We define symbols. Labels. Register labels. We take a function offset. Offset plus offset. Now this label offset, self-instructions iter enumerate, offset times 2. Is this what I'm just missing? Is this it? Offset. Wait. Why did multiplying by that by 2 break? Oh. Is it because I have to do this? Okay, cool. So let's try this. We end up at the end, and we end up with 1, which still isn't what I expect. I expected 5, but that's something. Okay, let's recompile this, chuck it in here, reset, compile, run. And we overflow the stack. Or something like that. So let's just return a different sequence and see how it goes. This is a very different sequence. And this still, so recursion is not quite working. Oh, nice. This is a cool little grammar. Let me just pull this up on stream real quick. This is how a professional defines their language. This looks good. Good old, what's this? BNF? eBNF? Untangled Co. Thank you very much for the raid. That's really exciting. I haven't had a raid for a little while. Welcome. Puy ASP2, you're following. Thank you so much. Where are you guys coming from? Untangled Co. What were you guys doing? What was happening over there? What was happening over there? Hello, hello. You know, I like someone jumped into this stream. Untangled Co, you got to jump to a birthday party. All good. Thank you so much for the raid. Thanks so much for sharing the love. I'm probably not going too much longer, sadly. Building an RTP protocol lib from scratch. That sounds really cool. Sounds like the kind of stuff I'm into. This is not my eBNF. This is someone else's. The viewer just sent this in. But that's cool. That's cool. Yeah, cheers. Thank you. Thank you. You look after yourself as well. Get Sag, get high. Thank you very much for the follow. Fantastic name. Okay. Recursion is broken. Recursion is broken. Let's go back. Now let's just do this. So we're just adding up numbers, right? 1 plus 2 plus 3 plus 4 plus 5. I've called it fib because it's going to be Fibonacci numbers eventually, but it's not working. Recursion has broken. So let's just compile this. Let's throw it in to our virtual machine. We're going to reset. We're going to compile, and we are going to do the most tedious thing possible and just step through this line by line. So if you guys coming into chat, if you've got any cool stories, any cool programming stuff you want to ask about, now is the time to do it, because this is going to be snooze time for a minute while I click through. So this is a good time to chat. This is a good time. Ask me anything about myself. You know, ask me questions. We are jumping around. That immediate. This was giving me issues before. We're jumping to the right place now. This is really good news. This is fantastic news. Immediate 6, blah, blah, blah. What language is this? How long have I been coding for? Mayank. I started programming when I was about 8 years old, probably 7 or 8 years old, using Game Maker and doing a little bit of Python. That was not very productive for me. I wasn't very good at it. I was focused on music a lot in my early years. And so it's only really when I was 17, 18 that I started being able to write programs. But then I started my uni degree in 2016 doing a Bachelor of Computer Science. That's when I really knuckled down and learned how to code. I am building my own programming language in Rust. So my compiler's written in Rust. I've got all this funky code gen stuff going on in almost 500 lines of code. But then we're compiling into my own virtual machine bytecode for my own 16-bit virtual machine that I've written. So everything is here. Bobius says, recursion is being helpful and teaching me about what needs to be fixed. Can I give you my grammar? I do not have an eBNF grammar. I didn't do that. I've written my own parser combinators. None of this is actually pushed yet, and I really should do it. But yeah, so I'll link the repo, and if you keep an eye on this, probably right after this stream, I will push something up here. But yeah, so the VM stuff is all in here, and hopefully there will be a bit more of the language stuff in there soon. It would be nice if recursion worked. It would be really, really nice if recursion worked. But yeah, I'm writing my own parser combinators, so it's all just a bunch of function soup, which is fun, which is cool, and which is really, really complicated. Okay, so push to the stack, add 0, then we jump back to here, 62. This is the loop, 62. We pull the base pointer off, we pull the program counter off, we reset the stack pointer, we jump to PC62. But our base pointer continues. What is this loop? How are we... PC62. PC62. Where is this? What are we doing? So step 62. We end up BP SP push, which is here, right? PC SP push. This offset isn't correct. How do I keep track of the parser? A recursive descent? No, it's parser combinators. So it looks like this. So, an expression is one of a binary operation or an expression left-hand side, or an expression left-hand side is either a literal character, they're all the building blocks, and you just put them together using functions. There's no magic here. I'm going to make a YouTube video and talk about how I built this and why parser combinators are really cool and powerful. But yeah, so all of my parser combinators, all the way back to the most basic definition of a parser, all the way up through all of my combinators, doing all kinds of weird generic soup. All this I wrote. which has been very interesting and very rewarding and very frustrating all at the same time. I don't understand what's going on here. This is a function call, right? So after we do this test, yeah, recursive descent, that's a lot more common to see with like, yeah, EBNF stuff. Much more, I guess, standard if you're using like Yak or tools like that. But yeah, parser combinators, like go learn some, like Haskell is really good at parser combinators, Rust is really good at parser combinators. You need that kind of more functional framework, but they're very, very powerful. Okay, so my recursive jump is not being calculated correctly. So when we come in here, right, our main... Oh. We're actually writing some garbage to the section of memory that the screen lives in, which I didn't expect. That's fun. Okay, so our program starts, we do some stuff, we jump over to address 16, which is here, then we go through, we do some more stuff, test LTE. Oops. Let's take offset, blah, blah, blah. I don't think this is right. This doesn't look good. Where do we jump to the function? 130, C, SP push, link stack offset, blah, blah, blah. SP0BP. I don't know what this jump is. I don't understand. 62, SP push, BP. Let's maybe say add C0. So this is the end of a function. Why is this function doing so much? I'm a bit confused. This often happens. I feel like maybe I've like copy and pasted funny. That would explain some of that. Not all of it, but some of it. So let's step through a couple of instructions. So we jump into main here. Now, where do we jump in to 62? So 62 is the start of this function in theory. C1, SP push, blah, blah, blah. Push pop. This looks good. This looks okay now. C1, push. This looks fine. But then we overflow the stack. Okay. I think I copy and pasted weirdly before. I think that's the only explanation for what was going on there. I think that's the only possible explanation for what was going on there. So we're going to click through a little bit more. Push, pop, blah, blah, blah. We test. We jump to the falsy part of the condition, which is good. We jump back to 62. This is the start of the function call again. C, SP push. C, BP0, so BP3. So this is argument, this is the first argument. Is this an argument? Let's see what goes in. Well, 4 goes into C here, and that feels good. So some stuff happens, and then we're gonna jump back at some point to here, and we expect 3 to be in C, which is good. So we do some stuff, and then we're gonna jump backwards again. So now we're calling the next recursive iteration of the function. We're gonna grab 2, which is again, we're reaching the base case, right? We're coming down. 1, this is good. Now when we do this test, we expect to jump through to the truthy case where we're gonna do some stuff. We're gonna jump to PC 100, push load stack offset. And we shouldn't jump back here. We shouldn't, but we do. And now things are getting crazy because now when we load C for our recursive case, we get garbage. We get absolute garbage. This is what's happening. Okay, so the problem has to be in our code gen, when we when we compile an if statement, the true part is not being done properly. This block, what does this look like? So we're gonna see this jump, and it's when we jump to PC 100. So here. So we should skip over this and go straight to 130. And 130 should be here, right? Where we actually return from the function. But we somehow don't get here. You get int 16. Yeah, you int 16 max. Yeah. Because I'm just getting garbage off of the stack, basically, right? Okay, so let's step through again. Let's do this one more time. I really need to do breakpoints. I really need to do some kind of conditional breakpoint. That would be really, really good. So 4, 3, 3, 2. Okay, we're getting to the base case. So when we jump back again, this is where we get to the pointy end. Okay, so we load 1, right? We load 1 because this is our argument. This is what we've passed in. We want to see if this is less than or equal to 1. So we're going to step. We push it onto the stack. We pop B off of the stack. We pop C off of the stack. Is 1 less than or equal to 1? BC LTE, right? This is true. This is true. B is, wait. The order of these things matters. The order of these things matters. In this case, I think we're okay. So this is true, right? So this is true. So what happens after this? So LTE, where's our LTE? C01. So if this is true, we're gonna set C to 1. Now, or 2. That's okay. That's okay. Register +2 offset value. This is okay. This is okay. But this still isn't... no, because this is true, yeah. So because this is true... Wait. Why am I... Wait. I feel like I've done something... yeah, no, this is good. This is good. This is okay. Then we have to do this. We have to do this extra bit. It's a bit silly, but it's okay. We put C on the stack, and we test if C is 0, which is false. So we're not going to skip over here. Huh. So why did that happen? Wait. Let me step through this again. Okay, let me do this one more time. If I don't work out what's going on, I'm going to stop for the day, but I'm going to try this one more time. One more time. Okay. So we push it to the stack. We do all this stupid manipulation. We do this test, and the flag does not get set. Now we add... But the flag's not set, right? I can see the flag's not set. So why does C become 1? Because I didn't 0 C beforehand. Oh my god. Oh my god. It's really silly. It's really, really silly. Add if... less than or equal, yeah, it's this one. So before we do this add if, we're gonna 0 C. 0, 0, 0. Okay. So now it's just gonna work. It's gonna work first time. Almost. Reset. Compile, run. Okay. We're getting better though. We're getting better. C, push, load, push, less than or equal to, add 0 to C, set C. Okay, now we're cooking. Now we test if C is 0. That wasn't right though. Why did we go back to PC10? Why? What? What? Wait, I think I missed an important step there. Add if C0 and then add if 4 C SP push. Wait, where did we get back to SP10? What the hell? Compile. Step. Okay, here we go. Let's do that again. Less than 0, add if C1, push, pop. Okay, so this is true. But somehow we end up at the wrong PC. This has to be a numeric issue, right? U16, that's fine. So we're not wrapping around because that would be a runtime issue. Step. I said I'd do this one more time, but I lied. 72, 74, 76, 8, C01, push, pop, 0, 8. We go back to 8. This is good. Wait. Add if. Hold on. Every time I've done add if, I've done it wrong. It adds, it doesn't add to this register. This is the destination. It adds this to this and stores it here. So every add if we have, which is only 2 of them, thankfully, was wrong. Okay. I see it now. Compile, run. Still not quite there. Step. Here we go. Okay. So now 62. Okay. Sub, push, sub. Now we get stuck in this weird loop again, somehow. Reset, compile, run. I don't know. I don't know what's happened. I don't know what has happened. Compile, reset, compile, run. Reset, compile, step. Okay, what's going on? Push, 0, 62. Okay, so we grab the number, we push it, we do this less than equal, it fails, C is 0, we push, we pop, we test, this is true now, so we jump ahead to stack ASP pop. So we put something in the A register. Yes. Okay. We take whatever's on the stack into the A register, and then we add him signed. We subtract from the stack pointer, in fact. And then we go back to PC6. Our frame has been corrupted. We shouldn't be... Okay, we're in an infinite loop. This has gotten a little bit messy. This has gotten a little bit out of hand. I'm going to call it there because I can feel my brain starting to rot. But I'm going to raid someone because I've got a couple of viewers. So if anyone has a fun channel that they'd like to see raided, feel free to shout them out. I'll chuck a couple of viewers their way. What have we got? Game dev. Procedural FPS. That sounds kind of cool. I like a bit of FPS. Aussie game dev. I'll host a fellow Aussie, right? Who's this person? Sninko Games. Let's give him a little raid. Let's do a quick preview. Just make sure they're not a weirdo. But yeah, they seem chill. Let's do it. Mates like mates. That's it. Gotta throw them onto an Aussie. All right. I'm going to start the raid. I'm going to call it there. Thank you everyone for tuning in. It's been a very productive stream. I've got a lot done. Stuff has happened. It's moving, it's happening. And then we're going to go and check out what this guy is up to. Thank you all so much. And I will catch you next time.